Welcome to MeritHub. If you know that we are discussed the previous year question on the basis the mechanical engineering, the subject is fluid mechanics. Those students are going to um, preparing or those are prepare for the different types of state JEE and SSC JE or BJE, that type of the examinations. The previous year question is the key of success or key of rank. Okay, it's very important every students. So in the sessions we discuss the previous year questions. This session is for the only mechanical engineers. Okay, let's start the session. Before starting, those students are new in my channel, please subscribe. Okay, let's start. The first questions. First question, friends. The absolute pressure at a depth of the 500 centimeter below the surface of liquid of relative density 0.85 is equal to. We know the um, equation of the pressure on depth equal to pressure equal to d uh, rho g h, where rho is the density, g is the gravitational acceleration, h is the height or the depth of the uh, depth from the free surface. In this equation you put the values. Okay, where the rho g equal to 0.85. Okay, and the h equal to 5 500 centimeter, it's converted into then you get the answer is megapascal. So 500 centimeter means into 10 to uh, 2 millimeter. And this answer is coming the gauge pressure. You add the atmospheric pressure, then you get the absolute pressure. Here the full solution. As I say, the P equal to rho gh, where 850 kg per meter cube. This is the relative density. Absolute atmospheric pressure, we know that the 101,325 pascals, it's converted into 10 to the minus 6 megapascal. Then you can get the gauge pressure. Add those two pressure, you can easily get the absolute pressure. The absolute pressure is this 0.141 megapascal. Next question, friends. If density of mercury is 13.58 gram per centimeter cube, pressure of the 4 kilopascal is equivalent to. Simply first it's converted into a gram per cube. We know the 1 centimeter equal to 10 square 10 square Okay, then 10 to 4, it's above into 13.58 into 10 to power minus 4. This is the density of the mercury in CGS unit. The pressure is 4 kilopascals. Then the equivalent, it's equal to P equal to rho gh, where P is the 4000 pascal. 4000 divided by 3.58 into 10 to power minus 4 into 9.81, you can get the of He. Let's check. This is the full solution. If we put the data, you can get 30.04 mm. Okay. Next question, friends. In case of a body, the resultant pressure of the liquid acts through the center of pressure, the center of gravity, the meta center, the center of buoyancy. The center of pressure. Next question, friends. In context of the hydrostatic, which statement is true? Center of pressure and the center of gravity coincide. B. Center of pressure does not exist. Center of pressure always lies above the center of gravity. Center of pressure always lies below the center of gravity. D. Center of pressure always lies below the center of gravity. Here the explanation in details manner. In the context of hydrostatic, center of the pressure lies below the center of the gravity because the pressure intensity always increase with the increase in depth. Center of the pressure always lies the below centroid of the plane surface, but when the depth of the submerged body is very large in comparison to the dimension of the plane surface, then the center of pressure almost coincide with the centroid of the plane surface, so that when the depth of the submerged body increase, the center of pressure moves towards the centroid plane surface. Vertical distance between the center and the center of the pressure and the centroid mm, decreases. Okay. Next question. Question number 305. A simply U-tube manometer connected to a pipe in which liquids flowing with the uniform speed will give which kind of the pressure? Gauge pressure, none of these, absolute pressure, vacuum pressure. Gives the gauge pressure. Okay. I have already completed the 11 sessions. Those students who are not see the previous classes, please go through the playlist in my channel and watch the video. A simple U-tube manometer connected to a pipe in which the liquid flowing with the uniform speed will have the gauge pressure. Manometer, it is a device used to measuring the pressure at point in a fluid by the balancing of the column of the fluid by the same or the another column of the fluid. They are the classified into the simple manometer and the differential manometer. Okay. U-tube manometers, it consists of the glass tube band in the U shape, one end of which is connected to a point at which the pressure is to be measured and other end remains open to the atmosphere. U-tube manometer measures the both positive and the negative gauge pressure. It is used for the high pressure measurement. Question number 306. A breaker, a half beaker, half filled with the water, is exposed to the atmosphere. If the pressure at a point A, B, and the C shown in figure, the PA, PB, PC, respectively, which of the following will be relation connecting the three? Okay. In this equation we can say the in this picture we realize that the pressure B and the C is equal and the pressure A is less because the height is less, this height is more, so pressure A is less than the pressure B, equal to pressure C. Okay, A is the answer. Next question: which of the following device is not used to the measure the flow rate of the or the velocity of the fluid? Wire anemometer, current and the turbine meter, piezometer, pitot tube. Piezometer. Because in piezometer we measure the pressure of the fluid. Okay. Question number 308: the hydraulic intensifier is a device used to increase viscosity of fluid, volume of fluid, velocity of fluid, pressure of fluid. Hydraulic intensifier, it's pressure of fluid. Let's check the answer. Hydraulic intensifier is used to increase the liquid pressure above the available from a pump. The task is accomplished by the utilizing the energy of a large quantity of liquid at the low pressure. It is located between the pump and the application. Next question: an oil of the specific gravity is zero point 0.9 contained in the vessels at a point the height of the oil is 40 meter. Find the corresponding height of the water column at that the point. It's easy. The we know the pressure equal to rho gh. So rho gh of oil equal to rho gh of water. Here we put the specific gravity of the oil is zero point 0.9. Specific gravity means the rho g is zero point 0.9. It's zero point 0.9 into 40 divided by 9810, which is the specific weight of the water. You can get the answer. Let's check the answer. What is the answer? It's 36 meter. Sorry, specific weight of the water is the specific weight equal to weight of the fluid by the weight of the ideal fluid, which is specific weight is the one of the water. Next question, friends. Question number 310. The atmospheric pressure at the ground level is approximately uh, it's 1 kg per centimeter square, which is 101325 Newton per meter square of the Pascal. Next question: mercury is a suitable fluid for a barometer because it's very has very the low vapor pressure at the room temperature, has the high vapor pressure at the room temperature, weights of the glass surface, has low boiling point. I think the is the answer. Has the very low vapor pressure at the room temperature. Let's check the answer. Yes. A marker is suitable for the fluid for the barometer because it has the high density so that the column can be uh, a reasonable height. It has the very low vapor pressure at room temperature, no evaporation in vacuum tube. It has the high boiling point, non-wetting properties, easily purified and the chemical stable. It has the high volume expansion, no gravity or the temperature correction. Next question, friends. 1 Newton per meter square is equal to Newton per meter square is Pascal. So the answer is answer 1 Pascal. Next question, friends. What is the water pressure on the sea bottom? The depth is given. The specific gravity of the sea water is 1.03. So it's easy. In megapascals it's given. So first you convert this meter to mm. 10 to power 3 mm. Okay, 1 meter equal to so 6500 into 10 to power 3 into specific weight 1.03. You can get the answer approximately 65 megapascal. Let's check the answer. Yes, 65 megapascal. Question number next question. The pressure intensity at a point in a fluid at the rest 4 Newton per centimeter square. The corresponding height of the water would be first it's converted into Newton per meter square. So 1 centimeter equal to 10 to power minus 4 meter square. So it's 4 into 10 to power 4 or 10 to power 4 Newton per meter square or Pascal. Um, mm, it's equal to rho g rho gh. Okay, rho g equal to 1 sorry rho gh rho 9810. Okay, 9.81 into 1000 into age. It's divided by the 9810. You can get the answer. Let's check the answer. 4 into 10 to the 4 by the 1000 into 10, because here assume the g equal to 10, 4 meter. Sorry friends. Next question. In a conventional Bardon tube pressure gauge, the elastic element used for the converting pressure to deformation is of dash cross section: triangular, circular, square, elliptical. I think the elliptical. Let's check the answer. Yes, it's elliptical. Conventional Barton tube pressure gauge is a hollow tube with and the elliptical cross section. When a pressure difference exists between the inside and the outside, the tube tends to strengthen out and the end moves using the secondary device such as a ear nozzle or the transducer to convert it into and the electric signal. It measures the pressure difference. Mm, Piezometer are used to measure the velocity of the flow, gauge pressure, temperature, viscosity of the fluid. Piezometer are used to measure B gauge pressure. In this chapter, total one formula is given: pressure equal to rho g u g h. By using this formula, you can solve with all types of question of in this topic or in this chapter, which is the pressure measurement. Okay. Yeah, a tank containing the water up a height of 2 meter. Calculate the pressure at the bottom of the tank. P equal to rho g is same formula, where the rho g equal to 989810 into 2. It's Newton per meter square. 216. It's C is the answer. Let's check the answer. C is the answer. One torr is equal to the how much pressure? One torr equal to megapascal. It's atmospheric pressure. One atmospheric pressure. It is the how uh, it's I think the 101.3. Let's check the answer. I confused this question. 133. 1 torr equal to 10325 by 760 uh, pascal, so 133.32 pascals. Remember it. And 1 torr equal to 133.32 pascal. A U-tube manometer containing a liquid of the specific gravity S measures the gauge pressure of the water flowing in a pipe H2 equal to difference the level of the manometric liquid in the two limbs. H1 equal to height of the water between the point of the connection of the pressure tap and the level of the manometric liquid in the lamp, to connected by the a tube bending down. The measured gauge pressure equal to, okay, its weight of the water, H2S minus H1 of the water. I think B is the answer. It's B is the answer. Yeah, you can see the solution. Okay. Next question. A small pressure difference between the 2 points along a pipeline carrying the water is to be measured using the AU tube manometer. The manometric fluid to be used is, it's carbon tetrachloride. D is the answer. Let's check the answer. Yes, a small pressure difference between the 2 points along a pipeline carrying the water is to be measured using U2 manometer. The manometric fluid to be used in carbon tetrachloride. Sorry for noise, friends. Next question. When the pressure intensity at a point is more than the local atmospheric pressure, then the difference of these the two pressure is called barometric pressure, negative gauge pressure, positive gauge pressure, absolute pressure. Pressure intensity of a point is more than the local atmospheric pressure. Difference between its is the barometric pressure, I think. Sorry, positive gauge pressure. Absolute gauge pressure absolute minus atmospheric pressure. Difference is the when the pressure intensity at a point is more than the local atmospheric pressure, then the difference of these two pressure is called the positive gauge pressure. The pressure in a stationary water column varies non-linearly with depth. Increase with depth depends on the viscosity of the depth. Is constant with depth. Increase with depth. P equal to rho gh. P directly proportional to depth. Next question, friends. Determine the total pressure on a circular plate diameter 1.5 meter, which is the placed vertical in the water in such a way that the center of the plate 3 meter below the surface of the water. The total pressure equal to total pressure or the hydrostatic force equal to rho g a h bar, where the area is rho g 99810 into area equal to pi by 4 dq 1.5 cube, and the h bar equal to the circular 5. This is the center to distance in 3, so into 3 you can get this, solve this, you can get the answer. Its answer is 52002.81 Newton. Okay, simply rho g a h bar. Here is x bar. Bardon gauge measure the absolute pressure, gauge pressure, local atmospheric pressure, vapor pressure. Bardon gauge it's measure the gauge pressure. Let's check the answer. Sorry, I am wrong. The Bardon gauge measure the local atmospheric pressure. Question number 2 to 5. The difference of the presence of head by the difference UT manometer used for the measure of the difference in the pressure of the oil where through the pipe is the given. Manometric liquid specific grade of the oil in the mercury level. Uh, U2 differential U2 manometer. Uh, this is a x into x is the manometric reading and specific gravity of the manometer metric liquid by the the vial minus 1. Let's check the answer. Yes, b is the for the inverted U2 manometer. Thank you friends watching this video. Those are new in my channel, please subscribe my channel and join every live. Okay, because the previous year question is most important for us. Thank you. Here I close this session.